Question 1. Given that vector OP equals -3, 1, and vector OQ equals 2, 5, what is vector PQ? Vectors OP and OQ are position vectors drawn from the origin. Here is position vector OP, where P has coordinates -3, 1. Here is position vector OQ, where point Q has coordinates 2, 5. To find the components of vector PQ, firstly we consider the horizontal component, and that is found by finding the difference between 2 and -3. So 2 minus 3 is equal to 5. Next, we consider the vertical component of vector PQ, and that is found by finding the difference between 5 and 1. So 5 minus 1 is equal to 4. Therefore, vector PQ has components 5, 4. Therefore, the answer is option C. Question 2. Which of the following integrals is equivalent to the integral of sine squared 3x dx? Recall that cos 2x is equal to 1 minus 2 sine squared x. Hence, cos 6x is equal to 1 minus 2 sine squared 3x. Switching both sides of the equation around, we have 1 minus 2 sine squared 3x is equal to cos 6x. Multiplying both sides by -1, we have 2 sine squared 3x minus 1 is equal to negative cos 6x. Adding 1 to both sides of the equation, we have 2 sine squared 3x is equal to 1 minus cos 6x. Dividing both sides by 2, we have sine squared 3x is equal to 1 minus cos 6x all over 2. Therefore, the answer is option B. Question 3. What is the remainder when p of x equals -x cubed minus 2x squared minus 3x plus 8 is divided by x plus 2? The remainder may be found by substituting x equals -2 into the polynomial. So we'll start off by typing -2 into the calculator, press shift, and then store, and then x. Next we can type out the polynomial. So negative x cubed, so alpha x cubed, minus 2x squared, so alpha x squared, minus 3x, plus 8, and that equals 14. Therefore, the answer is option D. Question 4. Consider the differential equation dy over dx is equal to x over y. Which of the following equations best represents this relationship between x and y? This is a separable differential equation. So we'll start by separating the variables by cross multiplication. Hence, y dy is equal to x dx. Next, we'll integrate both sides. So the integral of y with respect to y is equal to the integral of x with respect to x. And we get y squared is equal to x squared plus the constant c. Therefore, the answer is option A. Question 5. For the two vectors OA and OB, it is known that the dot product of OA and OB is less than 0. Which of the following statements must be true? The dot product of vectors OA and OB is given by the magnitude of vector OA multiplied by the magnitude of vector OB multiplied by the cosine of the non-reflex angle between vectors OA and OB. Now the magnitude of vector OA is greater than 0. The magnitude of vector OB is greater than 0. Hence cos theta must be less than 0 since the dot product is negative. Therefore theta must lie between pi over 2 and pi, which means that theta is obtuse. Hence the answer is option B. Question 6. The random variable x represents the number of successes in 10 independent Bernoulli trials. The probability of success is p equals 0.9 in each trial. Let R equal the probability that X is greater than or equal to 1. Which of the following describes the value of R? The probability of at least one success is equal to 1 minus the probability of no successes in 10 trials. So using complements, that equals 1 minus 0.1 to the power of 10, which equals 0.999 and so on. Therefore, the answer is option A. Question 7. Which curve best represents the graph of the function f of x equals negative a sine x plus b cos x, given that the constants a and b are both positive? The strategy here is to find the y-intercept and then consider the gradient of the tangent at that y-intercept. When x equals 0, f of 0 is equal to negative a multiplied by sine 0 plus b cos 0. Now sine 0 is equal to 0 and cos 0 is equal to 1. Hence f of 0 is equal to b and b is greater than 0. Hence two answers that are not possible are options A and C, since their y-intercepts are both negative. The next consideration is the gradient of the tangent at the y-intercept. F dash of x is equal to negative a cos x minus b sine x. F dash of 0, so the gradient at the y-intercept, so when x equals 0, is equal to negative a cos 0 minus b sine 0. Now sine 0 is equal to 0 and cos 0 is equal to 1. Hence f dash of 0 is equal to negative a, which is negative. Hence the answer is option D, since the gradient of the tangent at the y-intercept is negative. Question 8. The diagram shows a semicircle. Which pair of parametric equations represents the semicircle shown? The radius of the semicircle equals 1 unit. The domain is x greater than or equal to 2 and less than or equal to 4, and the range is y greater than or equal to 1 and less than or equal to 2. And that can be seen by observing the coordinates of certain key points on the diagram. Now for t greater than or equal to negative pi over 2 and less than or equal to pi over 2, cos of t is greater than or equal to 0 and less than or equal to 1, and sine of t is greater than or equal to negative 1 and less than or equal to 1. Combining the domain and range here with this result here, we get 3 minus sine t is greater than or equal to 2 and less than or equal to 4, and 2 minus cos t is greater than or equal to 1 and less than or equal to 2. Hence the answer is option C. Question 9. Which graph represents the function y equals the inverse sine of x? Firstly, we'll consider the domain of the composite function, and that's equal to the domain of the inner function sine of x, which is all real x. Therefore, it cannot be option C, since the domain of option C is clearly not all real x. Next, we'll consider the range of the composite function, and that's equal to the range of inverse sine of x. Y will vary from negative pi over 2 to pi over 2. Therefore, it cannot be option B, since option B does not include negative pi over 2. And it also cannot be option D, since the range of option D extends beyond negative pi over 2 to pi over 2. Therefore, by the process of deductive reasoning, the answer is option A. Question 10. The members of a club voted for a new president. There were 15 candidates for the position of president and 3,543 members voted. Each member voted for one candidate only. One candidate received more votes than anyone else and so became the new president. What is the smallest number of votes the new president could have received? The solution to this problem is based on the pigeonhole principle. Now, each candidate on average received 3,543 divided by 15 votes, which equals 236.2 votes per candidate. But the number of votes cast is an integer, not a decimal. And one candidate was the winner and got voted president, which means that that candidate would have received more than 236 votes. So I would like to find out how many more votes that candidate would have received, at least as a minimum, to have been voted the president. Now, something else to be mindful of as well, that one candidate received the most votes, not at least one, which means there was a clear winner. Now, 3,543 minus 15 multiplied by 236 votes means that there were 3 votes remaining that need to be allocated to some candidates. So if we just assume that each candidate received 236 votes, not 0.2, but just 236 as an integer, multiply that by 15, subtract that from 3,543, which means that there's 3 votes floating around that need to be allocated somewhere. Now, by the pigeonhole principle, one candidate would get 2 out of those 3 extra votes, or those 3 votes remaining. So if we take 236 as the integer and then add the 2 extra votes that that candidate would have received, the minimum that candidate would have received to be the winner would equal 238. So therefore, the answer is option C. Question 11a. Find the sum of the vectors I plus 6j and 2i minus 7j. Adding 2 vectors expressed in component form can be done by summing each dimension or component separately. The first vector is I plus 6j, so that's 1 unit to the right, 6 units up, plus the second vector, which is 2 units to the right and 7 units down. So adding each component separately, we have I plus 2i, which is 3i, and we have 6j minus 7j, so 6 units up, 7 units down, which is negative 1j or just negative j. So the sum of the 2 vectors is 3i minus j. Question 11b. Expand and simplify 2a minus b in brackets to the power of 4. Apply binomial expansion using Pascal's triangle. So 2a minus b in brackets to the power of 4 is equal to 4 choose 0 multiplied by 2a to the power of 4 multiplied by negative b to the power of 0 plus 4 choose 1 multiplied by 2a to the power of 3 multiplied by negative b to the power of 1 plus 4 choose 2 multiplied by 2a to the power of 2 multiplied by negative b to the power of 2 plus 4 choose 3 multiplied by 2a to the power of 1 multiplied by negative b to the power of 3 plus 4 choose 4 multiplied by 2a to the power of 0 multiplied by negative b to the power of 4. So simplifying this expression, we get 16a to the power of 4 minus 32a cubed b plus 24a squared b squared minus 8ab cubed plus b to the power of 4. Question 11c. Use the substitution u equals x plus 1 to find the indefinite integral of x multiplied by the square root of x plus 1 dx. Starting with the substitution u equals x plus 1, differentiating with respect to x, we get du dx equals 1. Multiplying both sides by the differential dx, we get du equals dx. Also, rearranging the substitution to make x the subject of the formula, we get x equals u minus 1. Now, in the original integral, we're going to replace the dx with du, since du equals dx. We're going to replace x plus 1 with u, and we're going to replace x with u minus 1. So the integral becomes the integral of u minus 1 in brackets multiplied by the square root of u du. Expanding the brackets, we get the integral of u multiplied by the square root of u minus the square root of u du. Converting surd form to index form, we get the integral of u to the power of 3 over 2 minus u to the power of half du. Integrating both terms, that equals 2 over 5 multiplied by u to the power of 5 over 2 minus 2 over 3 multiplied by u to the power of 3 over 2 plus c. And substituting out the u and substituting in its place x plus 1, since the original integral is with respect to x. That equals 2 over 5 multiplied by x plus 1 to the power of 5 over 2 minus 2 over 3 multiplied by x plus 1 to the power of 3 over 2 plus c. Question 11D. A committee containing 5 men and 3 women is to be formed from a group of 10 men and 8 women. In how many different ways can the committee be formed? This is an unordered linear arrangement, so combinations will be used, not permutations. We'll also apply the fundamental counting principle to determine the total number of committees that may be formed. There are 10 choose 5 ways of choosing 5 men from a group of 10, and there are 8 choose 3 ways of choosing 3 women from a group of 8. So applying the fundamental counting principle here, if we take 10 choose 3, multiply it by 8 choose 3, we get the total number of committees that may be formed. So that's 10 factorial over 5 factorial 5 factorial multiplied by 8 factorial over 5 factorial 3 factorial, and that equals 14,112 committees. Question 11E. A spherical bubble is moving up through a liquid. As it rises, the bubble gets bigger and its radius increases at the rate of 0.2 millimeters per second. At what rate is the volume of the bubble increasing when its radius reaches 0.6 millimeters? Express your answer in cubic millimeters per second rounded to 1 decimal place. The rate of change of the volume of the sphere with respect to time can be expressed as a product of related rates. dv dt, so the rate of change of the volume of the sphere with respect to time, is equal to dv dr, which is the rate of change of the volume of the sphere with respect to its radius, multiplied by dr dt, which is the rate of change of the radius of the sphere with respect to time. Now the formula for the volume of a sphere is given by v equals 4 over 3 multiplied by pi r cubed, and differentiating this with respect to r, we get dv dr is equal to 4 pi r squared. dr dt is equal to 0.2 millimeters per second, and that's given in the question. So we want dv dt when r is equal to 0.6 millimeters. So using the chain rule, dv dt is equal to 4 pi multiplied by 0.6 squared, so substituting 0.6 for r, multiplied by dr dt, which is 0.2, and evaluating the right hand side, we get 0.9047 and so on, and rounding this to 1 decimal place, that equals 0.9 cubic millimeters per second. Question 11F. Evaluate the definite integral from x equals 0 to x equals the square root of 3 of 1 over the square root of 4 minus x squared dx. The result of integrating an expression in this form involves an inverse sine function. It helps to note that the derivative of the inverse sine of f of x is equal to f dash of x over the square root of 1 minus f of x all squared. So it may help to convert the integrand into this form. In order to do that, we'll factorize 4 out of the expression 4 minus x squared, and the integrand will look like 1 over the square root of 4 outside of 1 minus x over 2 all squared. Taking the 4 outside of the surd, we get 1 over 2 multiplied by the square root of 1 minus x over 2 all squared. And that's equal to half over the square root of 1 minus x over 2 all squared. Now the derivative of x over 2 with respect to x is equal to half, and that's in the numerator. So the integrand is now in the form f dash of x over the square root of 1 minus f of x all squared. So integrating this expression, that's equal to the inverse sine of x over 2 from x equals 0 to x equals the square root of 3. Applying the limits of integration, that's equal to the inverse sine of the square root of 3 over 2 minus the inverse sine of 0, and that's equal to pi over 3. Question 11G. By factorizing, or otherwise, solve 2 sine cubed x plus 2 sine squared x minus sine x minus 1 equals 0 for x greater than or equal to 0 and less than or equal to 2 pi. Factorize the left-hand side by grouping in pairs. We have 2 sine cubed x plus 2 sine squared x, which forms the first pair of terms, and we have minus sine x minus 1, which forms the second pair of terms. Now with the first pair of terms, we can factorise out 2 sine squared x. So that can be written as 2 sine squared x outside of sine x plus 1. And with the second pair of terms, we can factorise out -1. So that becomes minus sine x plus 1 in brackets. So to complete the factorisation, we can write this expression as sine x plus 1 in brackets multiplied by 2 sine squared x minus 1 in brackets. Next, we solve the equation in factor form. So we're going to solve sine x plus 1 in brackets multiplied by 2 sine squared x minus 1 in brackets equals 0. And for this equation to equal 0, either one of these two brackets or both need to equal 0. And this can be split into two cases. So case 1, we have sine x plus 1 equals 0. Subtracting 1 from both sides, we get sine x equals -1, and therefore x equals 3 pi over 2 radians. And for case 2, we have 2 sine squared x minus 1 equals 0. Adding 1 to both sides, we get 2 sine squared x equals 1. And dividing both sides by 2, we get sine squared x equals half. And then taking the square root of both sides, we get sine x is equal to plus or minus the square root of 2 over 2, or plus or minus 1 over the square root of 2. So this means that there are going to be 4 angles. So we're going to have an angle in each quadrant. So when sine x is equal to positive root 2 on 2, that's quadrants 1 and 2, so x equals pi over 4 and 3 pi over 4. And when sine x is equal to negative root 2 over 2, x equals 5 pi over 4 or 7 pi over 4. Combining the solutions from both cases, we have x is equal to pi over 4, 3 pi over 4, 5 pi over 4, 3 pi over 2, and 7 pi over 4. Question 11H. The roots of x to the power of 4 minus 3x plus 6 equals 0 are alpha, beta, gamma, and delta. What is the value of 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta? The first step is to express 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta as a single fraction with a common denominator. And that equals beta gamma delta plus alpha gamma delta plus alpha beta delta plus alpha beta gamma over alpha beta gamma delta. Now it may help to rewrite the equation showing all the terms, including the terms that have a coefficient of 0. So the equation is x to the power of 4 plus 0x cubed plus 0x squared minus 3x plus 6 equals 0. Now the sum of the roots 3 at a time is equal to negative d over a, which equals 3. And the sum of the roots 4 at a time is equal to e over a, which equals 6. Therefore, 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta is equal to 3 over 6, which equals half. Question 12a. The direction field for a differential equation is given on page 1 of the question 12 writing booklet. The graph of a particular solution to the differential equation passes through the point P. On the diagram provided in the writing booklet, sketch the graph of this particular solution. Starting at point P, the curve drawn should run parallel to the tangent lines in the direction field. So to the left of P, the curve can be drawn something like this. So you can see that as much as possible, they're running parallel to the tangent lines and not crossing the tangent lines. And to the right of point P, again, keeping as much as possible parallel to the tangent lines. And this would be the particular solution that passes through point P. Question 12b. A bottle of water with temperature 5 degrees Celsius is placed on a table in a room. The temperature of the room remains constant at 25 degrees Celsius. After t minutes, the temperature of the water in degrees Celsius is capital T. The temperature of the water can be modelled using the differential equation d capital T dt is equal to K multiplied by capital T minus 25 in brackets, where K is the growth constant. Part 1. After 8 minutes, The temperature of the water is 10 degrees Celsius. By solving the differential equation, find the value of T when the temperature of the water reaches 20 degrees Celsius. Give your answer to the nearest minute. This is a separable differential equation, so we can start off by multiplying both sides of the equation by the denominator dt. So we get d capital T is equal to k multiplied by capital T minus 25 in brackets dt. The next step is to divide both sides of the equation by what's inside the brackets. So dividing both sides by capital T minus 25. And we get d capital T over capital T minus 25 is equal to k dt. Next, we integrate both sides of this equation. So the integral of d capital T over capital T minus 25 is equal to the integral of k dt. And that gives us ln of capital T minus 25 is equal to kt plus the constant c. Now, raising both sides of the equation to the base e, we get capital T minus 25 is equal to e to the power of kt plus c. And adding 25 to both sides, we get capital T is equal to e to the power of kt plus c plus 25. T is equal to e to the power of c multiplied by e to the power of kt. So that's breaking up this index there and writing it as a product of two terms. Now, e to the power of c is also a constant. So we're going to let capital A equal e to the power of c. Hence, capital T is equal to capital A multiplied by e to the power of kt plus 25. Now to determine the value of the coefficient capital A. When T equals 0, capital T equals 5. So the initial temperature of the bottle is 5 degrees. So substituting these values into this equation, we get 5 is equal to A plus 25. Now e to the power of kt, where t is 0, so that's e to the power of 0, is equal to 1. So now we can solve for A. So subtracting 25 from both sides, we get A is equal to negative 20. When t is equal to 8, capital T is equal to 10. 10 is equal to negative 20 multiplied by e to the power of 8k plus 25, and this equation can then be used to solve for k. So solving for the growth constant k, firstly subtract 25 from both sides. So we have negative 15 is equal to negative 20 multiplied by e to the power of 8k. Dividing both sides by negative 20, we get 3/4 is equal to e to the power of 8k. And taking the natural logarithm of both sides, we get ln of 3/4 is equal to 8k. Finally, dividing both sides of this equation by 8, we get k is equal to 1 over 8 multiplied by ln of 3/4. Now solving for t, when capital T is equal to 20, 20 is equal to negative 20 e to the power of kt plus 25. Subtracting 25 from both sides, we get negative 5 is equal to negative 20 multiplied by e to the power of kt. Dividing both sides by negative 20, we get 1/4 is equal to e to the power of kt. Taking the natural logarithm of both sides, we get ln of 1/4 is equal to kt. Dividing both sides of the equation by k, we get 1 over k multiplied by ln of 1/4 is equal to t. And we can substitute in now the value for k. So t is equal to 1 over 8 multiplied by ln of 3/4 multiplied by ln of 1/4. And we get t is equal to 38.55 ... minutes. And rounding this value to the nearest whole number, we get 39 minutes. Part 2. Sketch the graph of capital T as a function of t. Note that the growth constant k is negative. Hence, for the function capital T equals ae to the power of kt plus 25, as t approaches infinity, ae to the power of kt approaches 0, hence capital T approaches 25. The graph of capital T with respect to t will look something like this. So starting off at capital T equals 5 here on the y-axis, and approaching the asymptote t equals 25 as t approaches infinity. Question 12c. Use mathematical induction to prove that 1 over 1 times 2 times 3 plus 1 over 2 times 3 times 4 plus plus 1 over n times n plus 1 times n plus 2 is equal to 1 over 4 minus 1 over 2 times n plus 1 times n plus 2 for all integers n greater than or equal to 1. The first step is to show the statement is true for some value of n. And the smallest value of n that we can test is n equals 1. So we substitute n equals 1 into the right-hand side of the statement. Now the left-hand side of the statement is equal to 1 over 1 times 2 times 3, which equals 1 over 6. And the right-hand side of the statement is equal to 1 over 4 minus 1 over 2 times 1 plus 1 times 1 plus 2. And that equals 1 over 4 minus 1 over 2 times 3, which equals 1 over 6, which equals the left-hand side. Hence the statement is true for n equals 1. The next step is to assume the statement is true for n equals k, where k is some integer greater than or equal to 1. So that is 1 over 1 times 2 times 3 plus 1 over 2 times 3 times 4 plus plus 1 over k times k plus 1 times k plus 2 is equal to 1 over 4 minus 1 over 2 times k plus 1 times k plus 2. Next, we show the statement is true for n equals k plus 1. Now, this part of the statement, so the left-hand side, can be replaced with the right-hand side by the assumption. So 1 over 4 minus 1 over 2 times k plus 1 times k plus 2 is equal to the left-hand side. So what we need to do is take this side of the assumption and we're going to add on the next term, so the k plus 1 term. So we have 1 over 4 minus 1 over 2 times k plus 1 times k plus 2. That represents the left-hand side of the assumption, plus the next term along, which is 1 over k plus 1 times k plus 2 times k plus 3. I'll just make a statement here, so from the assumption. And that equals 1 over 4 minus k plus 3 over 2 times k plus 1 times k plus 2 times k plus 3 plus 2 over 2 times k plus 1 times k plus 2 times k plus 3. So adding these two fractions together by finding a common denominator, so multiplying this fraction here by k plus 3 over k plus 3, hence why we have a k plus 3 here and a k plus 3 there, and multiplying this fraction by 2 over 2. So we have two fractions now with a common denominator. So now we can add the numerators together. So that equals 1 over 4 minus k plus 1 over 2 times k plus 1 times k plus 2 times k plus 3. And the k plus 1 in the numerator cancels with the k plus 1 in the denominator here. And that equals 1 over 4 minus 1 over 2 times k plus 2 times k plus 3. And that equals 1 over 4 minus 1 over 2 times n plus 1 times n plus 2, since n equals k plus 1. So we can replace the k with n, and we end up with something that looks like the right-hand side of the original statement. So just make the point here, which is equal to the right-hand side of the original statement. So therefore, by the process of mathematical induction, the statement is true for all integers n greater than or equal to 1. Question 12d. A function is defined by f of x equals 4 minus 1 minus x over 2 all squared for x in the domain x less than or equal to 2. Part 1. Sketch the graph of y equals f of x, showing the x and y intercepts. The graph is a concave down parabola with vertex at 2, 4 in the domain x less than or equal to 2. Now the vertex can be read directly since the function is in completed square form. To find the y-intercept, we let x equal 0. So f of 0 is equal to 4 minus 1 minus 0 over 2 all squared, and that equals 3. To find the x-intercept, we let f of x or y equals 0 and solve for x. So we form the quadratic equation 4 minus 1 minus x over 2 all squared equals 0. Subtracting 4 from both sides and multiplying both sides by -1, so it does two steps in one, we have 1 minus x over 2 all squared is equal to 4. Taking the square root of both sides, we have 1 minus x over 2 is equal to plus or minus 2. Subtracting 1 from both sides, we have negative x over 2 is equal to -1 plus or minus 2, which corresponds to -3 or 1. And multiplying both sides by -2, we have x is equal to -2 or 6. But the domain of x is x less than or equal to 2. So we're only going to accept one of these answers. Hence, the x-intercept is -2. And here's the graph of y equals f of x. And I've shown here the x-intercept, the y-intercept, and also the vertex, even though the question doesn't ask for that. And it's also important to note that the range is y less than or equal to 4, and that'll be used in a subsequent part. Part 2. Find the equation of the inverse function, f inverse of x, and state its domain. To help make finding the inverse function a little easier, we can replace f of x with y in the function. So it can be written as y equals 4 minus 1 minus x over 2 all squared. Then we transpose or swap the x and y variables. So it becomes x equals 4 minus 1 minus y over 2 all squared. And then we make y the subject of the formula. So subtracting 4 from both sides and then swapping both sides of the equation around, we have negative 1 minus y over 2 all squared is equal to x minus 4, because we want the y on the left-hand side and the x on the right-hand side. Multiplying both sides by -1, we have 1 minus y over 2 all squared is equal to 4 minus x. And taking the square root of both sides, we have 1 minus y over 2 is equal to the positive square root of 4 minus x. Now note that the positive square root is needed since the point 3, 0 must lie on the graph of y equals f inverse of x. Since on the original graph, it passes through a y-intercept of 3, that means on the graph of the inverse, it must pass through an x-intercept of 3. And if we have the negative square root, then that point will not be on the graph. So from this line here, if we multiply both sides by -1 to make y positive, we have y over 2 minus 1 is equal to the negative square root of 4 minus x. Adding 1 to both sides, we have y over 2 is equal to 1 minus the square root of 4 minus x. And multiplying both sides by 2, we get y is equal to 2 minus 2 square root of 4 minus x. And then we can replace y with f inverse of x. Hence, f inverse of x is equal to 2 minus 2 square root of 4 minus x. And from part 1, the range of y equals f of x is y less than or equal to 4. Hence, the domain of y equals inverse f of x is x less than or equal to 4. So the domain and range get swapped around. Part 3. Sketch the graph of y equals f inverse of x. The graph of y equals inverse f of x is a reflection of the graph of y equals f of x in the line y equals x. Now the points 2, 4, 0, 3 and -2, 0 lie on y equals f of x. Swapping the coordinates around, 4, 2, 3, 0 and 0, -2 lie on y equals inverse f of x. So noting that, here is a sketch of the graph of y equals inverse f of x with the points 4, 2, 3, 0 and 0, -2 noted on the graph. Question 13a. A 2-meter high sculpture is to be made out of concrete. The sculpture is to be formed by rotating the region between y equals x squared, y equals x squared plus 1 and y equals 2 around the y-axis. Find the volume of concrete needed to make the sculpture. The sculpture is a composite solid formed by rotating the curve y equals x squared about the y-axis from y equals 0 to y equals 2 and subtracting from that the volume formed by rotating the curve y equals x squared plus 1 about the y-axis from y equals 1 to y equals 2. And that's the hollow formed in the sculpture. The volume V of the sculpture is given by the volume of the outer curve minus the volume of the inner curve. So that's pi multiplied by the integral from y equals 0 to y equals 2 of x squared dy minus pi multiplied by the integral from y equals 1 to y equals 2 of x squared dy. So this x squared here refers to the outer curve and this x squared refers to the inner curve. Now note that y equals x squared. We need this in terms of y. Hence x squared equals y. And for the inner curve, y equals x squared plus 1, and making x squared the subject of the formula, we have x squared is equal to y minus 1. So the integral becomes pi multiplied by the integral from y equals 0 to y equals 2 of y dy minus pi multiplied by the integral from y equals 1 to y equals 2 of y minus 1 dy. And that equals pi multiplied by y squared over 2 from y equals 0 to y equals 2 minus pi multiplied by y squared over 2 minus y from y equals 1 to y equals 2. Applying the limits of integration, we have pi multiplied by 2 squared over 2 minus 0 minus pi multiplied by 2 squared over 2 minus 2 in brackets minus 1 squared over 2 minus 1 in brackets. And that evaluates to 2 pi minus pi over 2, which equals to 3 pi over 2 cubic meters. Question 13b. When an object is projected from a point h meters above the origin with initial speed v meters per second at an angle of theta degrees to the horizontal, its displacement vector, t seconds after projection, is rt equals vt cos theta I plus negative 5t squared plus vt sine theta plus hj. Do not prove this. A person standing in an empty room which is 3 meters high throws a ball at the far wall of the room. The ball leaves their hand 1 meter above the floor and 10 meters from the far wall. The initial velocity of the ball is 12 meters per second at an angle of 30 degrees to the horizontal. Show that the ball will not hit the ceiling of the room, but that it will hit the far wall without hitting the floor. The trajectory of the ball follows a concave down parabola. The speed of projection is equal to 12 meters per second. The angle of projection is 30 degrees above the horizontal, and the height of projection is 1 meter above the floor. Now the equation that gives the displacement in the x or the horizontal direction with respect to time is x equals vt cos theta. And substituting in v equals 12 and theta is equal to 30 degrees, we get x equals 6 root 3 multiplied by t. And we'll call that equation number 1. The equation that gives the displacement of the ball in the vertical direction or the y direction with respect to time is y equals negative 5t squared plus vt sine theta plus h. And substituting in v equals 12, theta is equal to 30 degrees and h equals 1. We get y equals negative 5t squared plus 6t plus 1. We'll call that equation number 2. Now from equation number 2, the vertex of the parabola represents the maximum height reached. So the time to maximum height is equal to negative b over 2a, where negative b is equal to negative 6. It comes from this coefficient there. And 2a is 2 times negative 5, which is negative 10. And that occurs at 0.6 seconds after projection. So to find the maximum height, we substitute 0.6 into equation number 2. So that's equal to negative 5 multiplied by 0.6 squared plus 6 multiplied by 0.6 plus 1. And that equals 2.8 meters, which is less than 3 meters. Hence the ball will not hit the ceiling. Now from equation number 1, the time taken to reach the far wall, which is 10 meters away, can be found by solving the equation 10 equals 6 root 3 multiplied by t, making t the subject of the formula by dividing both sides of the equation by 6 root 3. And we get t is equal to 5 over 3 root 3 seconds. Now from equation number 2, I'll just go back to equation number 2 there. The height of the ball when t is equal to 5 over 3 root 3 seconds is negative 5 multiplied by 5 over 3 root 3 all squared plus 6 multiplied by 5 over 3 root 3 plus 1, which equals 2.14387 and so on meters above the floor. Hence, the ball will strike the far wall 10 meters away without hitting the floor or the ceiling. Question 13c. The region enclosed by y equals 2 minus the absolute value of x and y equals 1 minus 8 over 4 plus x squared is shaded in the diagram. Find the exact value of the area of the shaded region. The first point to note is that both functions are even, which means that we only need to integrate from x equals 0 to x equals 2, find the area, and then double it. The next point to note is that part of the area is positive, so that's the area bounded by y equals 2 minus x and the x-axis, but the other area is negative, so that's the area bounded by y equals 1 minus 8 over 4 plus x squared and the x-axis, and that needs to be taken into account when determining the total area. Now I've already stated that both functions are even, hence the area is equal to 2 times the integral from x equals 0 to x equals 2 of 2 minus x dx, plus the absolute value of the integral from x equals 0 to x equals 2 of 1 minus 8 over 4 plus x squared dx. And that equals 2 times the integral from x equals 0 to x equals 2 of 2 minus x dx, plus the integral from x equals 0 to x equals 2 of 8 over 4 plus x squared minus 1. So notice that these two terms have been switched around. So in order to turn a negative area into a positive area, I could multiply the integrand by negative 1 and remove the absolute value symbol. And that's equal to 2 times half times 2 times 2. So that's using the formula for the area of a triangle. And that's only half the triangle. So that's the right angle triangle from x equals 0 to x equals 2. So half the base times the height. Plus 4 times the integral from x equals 0 to x equals 2 of half over 1 plus x over 2 all squared dx minus the integral from x equals 0 to x equals 2 of dx, or 1 dx. Now note that 8 over 4 plus x squared is equal to 8 over 4 outside of 1 plus x over 2 all squared. So I factorized out 4 from the denominator. And that's equal to 2 over 1 plus x over 2 all squared. Also note that the derivative of the inverse tan of f of x is equal to f dash of x over 1 plus f of x all squared. So I'm turning this fraction here into a standard form to help with the integration. Now this fraction here is in that form, f dash of x over 1 plus f of x all squared. So carrying on from this line here, that equals 2 times 2 plus 4 multiplied by the inverse tan of x over 2 from x equals 0 to x equals 2 minus x from x equals 0 to x equals 2. And that equals 2 times 2 plus 4 inverse tan of 1 minus 4 inverse tan of 0, so that's applying the limit of integration, minus 2 minus 0. Now these 2's will cancel. And that equals 2 multiplied by 4 inverse tan of 1, which equals 2 multiplied by 4 multiplied by pi over 4, which equals 2 pi square units. Question 13D, Part 1. The numbers a, b and c are related by the equations a equals b minus d and c equals b plus d, where d is a constant. Show that sin a plus sin c over cos a plus cos c equals tan b. From the left-hand side, we have sin a plus sin c over cos a plus cos c. Now a equals b minus d and c equals b plus d. So that equals sine of b minus d plus sine of b plus d over cos of b minus d plus cos of b plus d. And expanding these trigonometric ratios of compound angles, that equals sine b cos d minus sine d cos b plus sine b cos d plus sine d cos b over cos b cos d plus sine b sine d plus cos b cos d minus sine b sine d. Now in the numerator, the sine d cos b terms will cancel, and in the denominator, the sine b sine d terms will cancel. So that equals 2 sine b cos d over 2 cos b cos d. And this 2 and this 2 will cancel, and this cos d and cos d will cancel there. And that equals sine b over cos b, which equals tan b as required. Part 2. Hence or otherwise, solve sine 5 theta over 7 plus sine 6 theta over 7 over cos 5 theta over 7 plus cos 6 theta over 7 equals the square root of 3 for theta greater than or equal to 0 and less than or equal to 2 pi. From part 1, tan b is equal to the square root of 3, a is equal to 5 theta over 7, and c equals 6 theta over 7. Solving for b, we get b equals pi over 3 or 4 pi over 3. So that's the angle in quadrant 1 or quadrant 3. Now we have values for a and c, which we have already established. So a equals 5 theta over 7 and c equals 6 theta over 7. Now again from part 1, we have two equations that relate a, b, c and d. So a equals b minus d and c equals b plus d. And we solve these two equations simultaneously to eliminate d. So adding these two equations together, so using the elimination method, we get a plus c is equal to 2b. Now to solve for theta. So 5 theta over 7 plus 6 theta over 7 is equal to 2 pi over 3 or 8 pi over 3. So that's doubling pi over 3 or 4 pi over 3. Adding these two fractions together, since they have a common denominator, we have 11 theta over 7 is equal to 2 pi over 3 or 8 pi over 3. Dividing both sides by 11 over 7, we get theta is equal to 14 pi over 33 or 56 pi over 33, which lie in the interval theta greater than or equal to 0 and less than or equal to 2 pi. Question 14a. A plane needs to travel to a destination that is on a bearing of 63 degrees. The engine is set to fly at a constant 175 kilometers per hour. However, there is a wind from the south with a constant speed of 42 kilometers per hour. On what constant bearing, to the nearest degree, should the direction of the plane be set in order to reach the destination? The following diagram represents a situation. Vector AB represents the desired bearing of the plane, 63 degrees from true north. Vector CB represents the wind from the south at 42 kilometers per hour, which acts on the plane in such a way as to push the plane or push the direction of the plane toward north. And vector AC represents the bearing that needs to be set in order to compensate for the wind pushing against the plane, which will be 63 degrees plus theta degrees. Now angle ABC is equal to 63 degrees. So we need another angle inside this triangle in order to either apply the cosine rule or the sine rule in order to be able to determine angle theta. So it's convenient to work out angle ABC since it's alternate. You can see a parallel line here and a parallel line here. So CB is parallel to SN. Now we have a known side angle pair. So AC is opposite angle ABC. So we can apply the sine rule to find angle theta. So by the sine rule, sine theta over 42 is equal to sine 63 degrees over 175. Multiplying both sides by 42 and taking the inverse sine of both sides, we have theta is equal to the inverse sine of 42 multiplied by sine of 63 degrees divided by 175. And that equals 12.347 degrees, which is approximately 12 degrees correct to the nearest whole number. Hence, the bearing set to compensate for the wind is 63 degrees plus 12 degrees, which is 75 degrees from true north. Question 14b. In a certain country, the population of deer was estimated in 1980 to be 150,000. The population growth is given by the logistic equation dp dt is equal to 0.1 p multiplied by c minus p over c, where t is the number of years after 1980 and c is the carrying capacity. In the year 2000, the population of deer was estimated to be 600,000. Use the fact that c over p multiplied by c minus p equals 1 over p plus 1 over c minus p to show that the carrying capacity is approximately 1,130,000. My first step was to express the differential equation without using decimals. So dp dt is equal to p outside of c minus p over 10c. This is a separable differential equation. Notice that the numerators of the fractions of both sides contain the variable p. The next step is to take the reciprocal of both sides. So we have dt dp is equal to 10c over p outside of c minus p. And using the given fact in the question, that's c over p outside of c minus p equals 1 over p plus 1 over c minus p, we can express dt dp as dt dp equals 10 over p plus 10 over c minus p. So splitting this fraction up into a sum of two fractions. Multiplying all terms by dp, we have dt is equal to 10 over p dp plus 10 over c minus p dp. Then we can take the integral of both sides, so integrating all terms of the equation, we get t equals 10 ln p minus 10 ln c minus p plus the constant d. And I've used the letter d so as not to confuse it with the letter c here. Now combining the two terms on the right hand side using log laws, since they both involve natural logarithms, t equals 10 ln of p over c minus p plus the constant d. Now when t equals 0, that's the initial population is 150,000, we can substitute t equals 0 and p equals 150,000 into this equation, and we get 0 equals 10 ln of 150,000 over c minus 150,000 plus the constant d, and we'll call that equation number 1. Now 20 years later, so the year 2000, when t equals 20, the population p equals 600,000, and substituting these two values into the equation, we get 20 equals 10 ln of 600,000 over c minus 600,000 plus d, and we'll call that equation number 2. Next, we're going to solve equations 1 and 2 simultaneously by eliminating d. So equation number 2 minus equation number 1, we get 20 equals 10 ln of 600,000 over c minus 600,000 minus 10 ln of 150,000 over c minus 150,000. And we can divide both sides of the equation by 10 and combine the right-hand side terms using log laws. We get 2 equals ln of 600,000 over c minus 600,000 divided by 150,000 over c minus 150,000, since the two terms involving logs are being subtracted. Now raising both sides of the equation to the base e to eliminate the ln, we have e squared is equal to 600,000 over c minus 600,000 multiplied by c minus 150,000 over 150,000. So I've changed the division into a multiplication and took the reciprocal of the second fraction. Now we have 600,000 over 150,000 equals 4. So dividing both sides by 4, we get e squared over 4 is equal to c minus 150,000 over c minus 600,000. Next we apply cross multiplication, so we're going to make c the subject of the formula eventually. So we have E squared multiplied by C minus E squared multiplied by 600,000 is equal to 4C minus 600,000. Taking the terms involving C over to the left-hand side and factorising out C, we get C outside of E squared minus 4 is equal to 600,000 outside of E squared minus 1. So the terms not involved or not involving C are taken over to the right-hand side. And then dividing both sides of the equation by E squared minus 4, we get C equals 600,000 multiplied by E squared minus 1 divided by E squared minus 4. And that equals 1,131,121.335, which rounds to 1,130,000 as required. Question 14c, Part 1. For vector v, show that the dot product of vector v and vector v is equal to the square of the magnitude of vector v. The dot product of vector v and vector v is equal to the magnitude of vector v multiplied by the magnitude of vector v multiplied by cos theta, where theta is the non-reflex angle between the two vectors. Now, since vector v is parallel with vector v, theta is equal to 0, hence cos of 0 equals 1. Therefore, the dot product of vector v and vector v is equal to the magnitude of vector v multiplied by the magnitude of vector v multiplied by 1, which equals to the magnitude of vector v squared as required. Part 2. In the trapezium ABCD, BC is parallel to AD, and the magnitude of vector AC is equal to the magnitude of vector BD. Let vector A equal vector AB, vector B equal vector BC, and vector AD equal K multiplied by vector BC, where K is greater than 0. Using part 1 or otherwise, show that 2 times the dot product of vector A and vector B plus 1 minus K multiplied by the square of the magnitude of vector B equals 0. From the diagram, vector AC is equal to vector A plus vector B, where vector AC is one of the diagonals of the trapezium, expressed in terms of the sum of vector A and vector B, where vector A is the left-hand side of the trapezium and vector B is the top of the trapezium. And vector BD is equal to K times vector B minus vector A, where BD is the other diagonal of the trapezium, expressed in terms of a difference between K times vector B, which is the base of the trapezium, and vector A, which is the left-hand side of the trapezium. It is given that the magnitude of vector AC is equal to the magnitude of vector BD. In other words, the two diagonals of the trapezium are equal in length. Squaring both sides of the equation, we have the square of the magnitude of vector AC is equal to the square of the magnitude of vector BD. From part 1, the square of the magnitude of vector AC is equal to the dot product of vector AC and vector AC, and the square of the magnitude of vector BD is equal to the dot product of vector BD and vector BD. Hence, the dot product of vector AC and vector AC is equal to the dot product of vector BD and vector BD. And from this equation, we can form an alternative equation using the lowercase notation. So vector AC is vector A plus vector B, and vector BD is K times vector B minus vector A. So we have the dot product of vector A plus vector B and vector A plus vector B is equal to the dot product of K times vector B minus vector A and K times vector B minus vector A. Expanding the brackets, we have this equation. And you can see that the dot product of vector A and vector A appears on the left-hand side and on the right-hand side. And that can be cancelled. And the terms on the right-hand side, so that's the K squared times the dot product of vector B and vector B, and the minus 2K times the dot product of vector A and vector B can be moved over to the left-hand side, so we end up with 0 on the right-hand side. Now the left-hand side can be factorised by grouping in pairs. So these two terms, we can take out 2 times the dot product of vector A and vector B. And for these two terms, we can take out a common factor of the dot product of vector b and vector b. So we have 2 times the dot product of vector a and vector b times 1 plus k, plus the dot product of vector b and vector b times 1 minus k squared equals 0. And notice here we have a difference of 2 squares. So we're able to form this equation here, so expanding the difference of 2 squares. Now we can divide all terms by 1 plus k since k is greater than 0, so there's not going to be any division by 0. So in other words, these terms will disappear. And we end up with 2 times the dot product of vector a and vector b plus 1 minus k in brackets times the magnitude, or the square of the magnitude of vector b is equal to 0 as required, since the dot product of vector b and vector b is equal to the square of the magnitude of vector b from part 1. Question 14D. At a certain factory, the proportion of faulty items produced by a machine is P equals 3 over 500, which is considered to be acceptable. To confirm that the machine is working to this standard, a sample of size n is taken and the sample proportion P hat is calculated. It is assumed that P hat is approximately normally distributed with mu equals P and sigma squared equals P multiplied by 1 minus P over n. Production by this machine will be shut down if P hat is greater than or equal to 4 over 500. The sample size is to be chosen so that the chance of shutting down the machine unnecessarily is less than 2.5%. Find the approximate sample size required, giving your answer to the nearest thousand. By the empirical rule, the upper 2.5% of the normal distribution with mean 0 and standard deviation 1 is from z-score greater than or equal to 2. P hat is approximately normally distributed with mu equals P, which equals 3 over 500, which as a decimal is 0.006, and the variance sigma squared is equal to P multiplied by 1 minus P over n, which equals 0.006 multiplied by 1 minus 0.006 over n, which equals 0.005964 over n, and we'll call that equation number 1. Using the z-score formula, we want P equals 4 over 500 to correspond to a z-score of 2. So from 1, a z-score of 2 is equal to 0.008 minus 0.006 over sigma, which is the square root of sigma squared. So we get 2 equals 0.002 over the square root of 0.005964 over n, which is just the square root of the right-hand side of equation number 1. Next, we solve for n. So the square root of 0.005964 over n is equal to 0.001. 0.005964 over n is equal to 0.000001. So that's squaring both sides. And making n the subject of the formula, we get 0.005964 divided by 0.000001, which equals 5,964, which is approximately 6,000. So approximately 6,000 samples will need to be taken. Question 14e. The polynomial g of x equals x cubed plus 4x minus 2 passes through the point 1, 3. Find the gradient of the tangent to f of x equals x multiplied by g inverse of x at the point where x equals 3. The first derivative of g of x, g dash of x, is equal to 3x squared plus 4. At the point where x equals 1, g dash of 1 equals 7. Given that g of x passes through the point 1, 3, g inverse of x passes through the point 3, 1. So notice that the coordinates have been reversed. So this coordinate has been reflected in the line y equals x. In fact, all the coordinates of the function g of x, when reflected in the line y equals x, have their coordinates reversed. And the value of the first derivative of g inverse of x at x equals 3 is the reciprocal of this value here, which is 1 over 7. And that's by the property of the symmetry of inverse functions. Now the following diagram demonstrates the idea. So here we have 2 points, so one point being reflected in the line y equals x. So this is a point on the curve y equals g of x, and this is the point or the reflected point on the curve y equals g inverse of x. So notice that the gradient at this point is 7, and the gradient at this point is 1 over 7. So one tangent is a reflection of the other in the line y equals x. Now, by the product rule, f dash of x is equal to g inverse of x plus x multiplied by the derivative of g inverse of x. Hence, f dash of 3 is equal to g inverse of 3 plus 3 multiplied by the derivative of g inverse of 3. Now, g inverse of 3 is equal to 1, since the coordinates have been reversed, plus 3 multiplied by 1 over 7, which is the value of the derivative when x equals 3 on the curve y equals g inverse of x. And that equals 10 over 7.